Hello everyone. So my name is Amar, and today I'll be talking about managing software components using Conan Package Manager. This on the image, as most of you probably know, is Conan the Barbarian. I'm not really sure if the Conan Package Manager got its name by Conan the Barbarian, but yeah, let's assume. So, okay, about me. If you know me, you probably know that I love C++ and I love talking about C++ in embedded development, but today I'm not going to talk about C++, unfortunately. Okay, so I'm head of engineering at Semblie, and my primary responsibility is software development. Okay, so let's first briefly discuss what software components are. So application-specific code is software component, but so is vendor-provided SDK libraries, but also things like code generators. So any Python script that generates C or C++ code for us is a software component. An example would be protobuffer. But also toolchain, so compiler, linker, everything that comes with toolchain is a software component, and also tools that we use for building our projects, such as CMake, Makefile, and so on, right? So those are all software components. How do we manage software components? These are some most usual ways that we deal with software components, and the most basic one and the most reliable one is, of course, copy-paste source code in our project folder and treat it as part of the project. The next step would be using things such as Git submodules in version control, and also build systems allow us to manage components to some extent. So if you are using CMake, you know we have functionality such as find package and fetch content that allow us to somehow manage dependencies. Right, and when it comes to toolchain and all other tools, we usually expect them to be installed in the system, or if we take a step further, we pack them in Docker container in order to be able to have kind of reproducible builds. So yeah, copy pasting sources. You've probably seen a project where you have a folder called third party, where we have all the third party libraries, probably vendor SDK and such, right? Git submodules gives us a bit more flexibility. So a submodule is a reference to a specific commit of an external repository, but this kind of makes Git workflow more complex, as we need to ensure that when we clone the project, we also clone submodules. So that's that. Here's a simple example of using Google Test as submodule. We have it in our project. It's located in tests folder. And in order to integrate it with our build system, Google Test has CMake that we can use. So from the top level CMake, we can use add subdirectory to include it and use it to link it against our target. CMake also offers find package. So it finds a package usually provided by something external to the project and load its package specific details. So what CMake does when we use find package, it looks on certain places for files name find package name.cmake or package name config cmake, and then it allows us to use it in our CMake project. So this would be an example of using Google Test to find package. We are using namespace gtest, and after that we link against gtest main target. So find package requires that Google Test is built and installed using CMake or installed in our system using systems package manager. So we need the crucial is that we need to have it installed, right? CMake also offers fetch content, which is a bit more flexible, as it allows us to specify URL of, let's say, a zip archive or even a link to a Git repo, and then use it further in our build system. Okay? When it comes to toolchain, we already said that we usually expect it to be present in system, or we are using Docker container to pack it and use it as that. So what's missing in this picture is there is no unified handling of all dependencies. So it would be great if we could handle all of these software components, all of these dependencies of our project in a uniform way. So if we could somehow treat sources, generators, build tools, and tool chains as some kind of packages that represent software components. Also, it would be great if we would have binaries for individual software components. So if we would have static libraries, but that are built for different architectures. So if we have a software component that we are reusing across different platforms, to be able to use them with different targets, with different architectures, and also to compile them not only for different architectures, but with different build options. Also, we would like to have cleaner build scripts. So using, let's say, fetch content CMake, we are kind of polluting our build scripts. Okay, why do we want this? We would like to have a better development experience. We would like to automate processes and make them less error-prone. We might want to have reproducible builds on different systems, such as Linux and Windows. We would like to have shorter build times in order to have faster development time and to have cheaper CI builds. What's the solution? Package Manager. So Package Manager allows us to treat all our dependencies as packages. So we treat sources, generators, tools, binaries as packages, and we can host them on servers. We can download them from a server, and we also can have them in our local cache on development machines and use them from local cache. We would also like that Package Manager does great deal of build process for us and to generate things such as toolchains, CMake files, and to create profiles with different build options. And we would also like to have version management, so that we have that we know which version of component we are using and which features comes with that version. Here's a pretty old question on Stack Overflow almost 10 years ago. Someone asked, does C++ have a package manager like npm, pip, gem, etc.? So this person comes from JS, Ruby background, and those are modern languages. Also Python that have native package managers, and people are used to using them. So those more modern languages are using package managers because they make things easier. Here are results of a poll. So I asked embedded developers how do they manage dependencies, and only minority of people answered other, and in the comments we were able to see they are using package managers. So package managers exist for C and C++, but they are not really used a lot. So people are still relying to these methods that we discussed previously. Okay, so Conan package manager to the rescue, right? Okay, so we will go through a workflow of building a simple demo project that's using Conan package manager. So Conan has something called Conan recipes, and they can be as simple as this txt file, but they are also more advanced methods using Python Conan file, which allows us more flexibility and more options. Let's go through this example using txt Conan file. So we have requires clause where we stated that our project depends on STM32F072 platform. This is a static library that provides us with whole. So we basically have SDK compiled into static library that we will be using in this demo. In tool requires clause, we specified ARM toolchain, and we stated which version of it we want to use. And in generators, we have few things that we will explain a moment later. We will use CMake as build tool for our project. Pretty simple CMake file. We create new executable, and we are using find package, and we are asking it to find STM32F072 platform, and then we link our object files against static library that comes from this namespace. So a moment ago we said that find package requires something external to provide places where to look for when it comes to finding packages. And that external in this case is Conan. So that generator, CMake deps, will generate everything that's needed for CMake to be able to find this package. Okay, I said we won't be talking about C++, so ignore this. Let's just take a note of what we are printing using printf. So we are printing hello embedded.ba. Okay, and here's Conan workflow. First we run Conan install. Then we are sourcing environment variables needed for building project. Then we are running configure phase of CMake. And after that, we are building project. We will break this down in individual steps now. Okay, so the first thing that we ran was Conan install. And what this does, it installs requirements specified in a recipe. So we specified that our project depends on STM32F072 platform. So Conan install will either use this package if it is present in our local cache, or it will download it from remote server, or it will build it locally. Conan install will also create necessary files as requested by generators, and we requested CMake deps, which will produce necessary files for each dependency to be able to use the CMake find package function to locate dependencies, and CMake toolchain. It produces the toolchain file that can be used in the command line invocation of CMake. We didn't specify toolchain directly as we used CMake presets. So we'll cover also that a bit later. So when we run Conan install command, we specify profiles. And in our case, we are specifying host profile STM32F072. And this is how profile looks like. So we have here settings. We state which compiler we are using for build options. And also in this profile, we specified CPP flags, C flags, linker flags, and defines. Okay, so what happens when you run Conan install? It first takes a look into profile we ask it for, and it makes sure that profile is there. It prints it out also. Then it computes dependency graph. And what this does is it takes a look in our recipe. It takes a look in all the dependencies that we stated, and it also checks dependencies of those dependencies. So if we take a look here, we have STM32F072 platform as a requirement, but as build requirements, we have ARM toolchain that we were able to see in our recipe, but we also see here CMake. So how did the CMake got here? That's the question. Okay, it then generates CMake deps and CMake toolchain files. Dependency graph. So as a first or second step of Conan install, we saw it computes dependencies. So we can also explicitly ask Conan to create dependency graph using Conan graph info command, and we can tell it to use HTML format, which will provide us with HTML file that looks something like this. So we see that our Conan file, that our recipe depends on STM32 platform and ARM toolchain. And we see that STM32 depends on ARM toolchain and CMake. So this is why we have dependency on CMake in our case. Okay, so what Conan install also does is it generates Conan build sh bash script, which allows us to source environmental variables, and in this case it will add path to toolchain in path, so we were able to use it. Okay, so Conan install also generates CMake presets, and we can see CMake user presets available in our directory after running Conan install. If we take a look in CMake user presets, we see it points to build release generator CMake presets, and this is the actual presets files that contains all settings needed for running configure phase of CMake and build phase of project. Okay, so here again we are using CMake preset to configure build system, and after that we are using it also to build the project. Okay, now it would be really cool if we were able to run this firmware that we just built. To do that, we will add Renode package as tool dependency, and Renode is a simulator that we will use to run the firmware that we just built. Okay, so when we include it in dependencies, we are now able to include CMake scripts that come with Renode package. So that's line 70, include Renode macros, and we are using add run in Renode target macro, which will create a new CMake target for us, and we provide it with Renode script file, which is a script file used by Renode to describe which microcontroller we want to use, and we provide it also to path to L file. So we are now rebuilding project, running Conan install again, configuring CMake, and building project, and we are now using target run in Renode. So after building project, it will start Renode, it will load this L file, and we see it prints out hello embedded.ba. Okay, yeah, so just a quick reference on main CPP, so that's what our firmware is basically doing. Okay, the next thing we want to cover is Conan cache. So after we built this project, we now have all of these components installed in our cache locally. So if we use Conan list command, we can list all components that are, all packages that are in cache, and we see here all components that we used in this demo project. Conan also has central repository. So CMake got in our project from central repository, and we can use Conan search with package name to search Conan central repository to see which versions of which packages are available there. But Conan is also decentralized package manager. So it allows us to, it has this client-server architecture, which means that clients can fetch packages from, as well as upload packages to different servers or remotes, similar to Git push-pull model. At a high level, the servers are just storing packages, so they are not building them. The packages are created by client, and the binaries and the entire packages are uploaded to this server. JFrog Artifactory is Conan server that we can install and maintain by ourselves. For anything that we want to have fully control of. Okay, that's it. Thank you.
So just check other person. Okay, so no questions on Slido, but if you have any questions here in person? Yes, please.
The server that stores the packages, is that you have to use the external guys, whatever the name is, or you can have a server internal for IP protection?
You can have it internally. I'm not sure on licensing, though, what kind of licenses are they using. There's community edition that's available to anyone, but I'm not sure on the license model. But yeah, you can maintain it by yourself. Yeah.
How many manufacturers supports Conan packaging? So, for example, you mentioned STM32. Maybe people who develop on that, they can use Conan package, but someone else can.
Yeah, that's a great question. Most of the packages that are available on Conan Center are not really suitable for embedded targets. The STM32F072 package was built by me. Yeah, so it comes with that, of course. But in a big picture, if we have enough manufacturers that would support that by themselves, then we would be able to utilize that with minimum effort from our end. But in this case, yeah, it was built by me. Conan takes some learning curve, but really it's not a lot. So creating packages such this one is not really a hard task. But of course, it comes with that. You need to create package, you need to maintain it by yourself. So there's cost of that, of course.
Similar question to that, you build simulator.
Yeah, also built by me.
Yeah.
I'm not selling here anything. I wanted to show what's possible and how our world of embedded development may look like.
Is it hard to make by yourself simulator?
No. It's easy.
Yeah, you can
Any other questions?
So let's imagine that we have a library that depends on OpenSSL version X. So and we actually want to use that library.
Okay.
But let's imagine that we also directly use another OpenSSL version.
You need to resolve that by yourself. It won't resolve it for you.
I have more questions. So, what if we want to use like different standard? How can we actually propagate that? Let's say that our top level standard is C++17, but we want to use C++23 in one of our dependencies. Can we actually use? How can we propagate that to that?
There are options that you can specify for packages. So you can say, I want this package with this option. So that's possible. And it's simple. So in what you would do in Conan recipe, you'd have options clause where you would specify package name and option from that package, and you'd say, I want it to be this.
Can we also have comments and not just questions?
Yeah.
So I want to add something because you mentioned Docker, but we can also use Nix to wrap all of that, to start what I'm doing. For example, in my case, I start from clean environment, just use mix, to basically always have the same environment.
Yeah. That's also an option, of course.
There was another question here.
Is your package available to others, or is it a private package?
No, I can make it available to others if you'd be interested. There is a link for my GitHub repo. No, there's no anywhere, but I'll make sure that everyone who took participation gets the link for this, and you will get access to all packages and to their Conan recipes and to instructions how to actually build it yourself.
I have another question.
Sure.
That's okay. So some package managers like Conan, for example, for Python, they come also with virtual environments that allow you to kind of keep multiple versions of the same package depending on the things you need to do. Does Conan offer also something like that?
You have Conan cache, so you're using components from cache. Okay. They're being used from cache, and it generates all the files required by build system to be able to find what exactly you asked it for in cache. So it's kind of similar thing. It does the same purpose.
Serves the same purpose. Okay. Anyone else?
Yes.
Yes.
It's less a question, maybe a little bit of a discussion.
Yeah, sure.
So I really like what you showed for dependency handling. It's much better, like you said, the GitHub modules and such. Of course, your project was, because of the dependency of the STM library, meant for a specific target.
Yeah, that's correct.
CMake philosophy is often like try to write projects for generic targets and such. Yes. Yeah. So you had built flags in your Conan configuration. So I didn't like that, for example. Because it's then a part of the repository, but I would like to rather have CMake repositories and projects that are like platform independent.
I understand. Yeah.
Is that really a focus of Conan to also provide those information, or is it a handle? Yeah,
it will generate it for you. So it generates all that stuff for you. So
you don't know what architecture I'm going to target.
Yeah, it can. So those are Conan profiles. So let me go a few steps back. Okay, so we have Conan profiles where you can specify architecture, where you can specify CPP flags, C flags defines.
Yeah, so this is part of the Conan specification.
No, you write this.
Yeah, you write this exactly, and I don't like that.
Okay.
You do that.
You don't like writing profiles?
Yes.
Okay, but
because I think it's something that shouldn't be part of the project.
It's not necessarily part of the project.
Yeah.
So you have project as it is, but this generates for you toolchain.
CMake. What it does later.
Okay.
Or where do you hold this profile?
You can hold it wherever you want.
You don't assume it to have it in the repository.
Yeah, that's correct.
Is Conan's focus on this topic also, or is it more on the package dependencies?
It's more on the package dependency, and this is something that you use to build.
Understand what it is.
To build packages.
Because I later will have a presentation which does this part in a different fashion.
Yeah.
I don't like this.
Okay. It's your flavor. But you can use the same profile to build different packages to fit this profile.
Yeah, of course.
Yeah. So,
but the focus is on dependencies generally, and maybe you force this in. I'm asking you.
No. It's part of Conan. Okay. So this is part of Conan, but when it comes to profiles, it's also up to you. How do you want to handle them? Where you want to have them stored, installed, and so on. Right.
Okay. After our presentations today, we will have to get together.
Sure.
To discuss this.
Welcome.
One more comment.
I have maybe a similar question, but for example, how would we handle cross-compilation using this? So using the whole infrastructure with CMake and Conan.
Okay, so profiles are doing that for you. So you specify generators, CMake toolchain, and that will generate CMake toolchain file using the profile. And then when you run Conan install, it will generate CMake presets, and which will contain information where to find toolchain CMake. That's also generated by Conan. Okay.